Hello everyone, my name is Avkash, and in this video we are going to learn the machine learning observability platform Comet ML. If you are an AI engineer, data scientist, or machine learning engineer who is responsible for building machine learning models and would like to track the machine learning model build process, then this video is for you. In this video, you will learn how you can utilize the Comet ML machine learning observability platform to track machine learning process during the training and after the training is completed. Just writing a few lines of code in your machine learning pipeline, you can integrate Comet ML platform to track your machine learning models. The framework is quite simple. All the metrics and other information related with your machine learning pipeline is sent from your runtime environment to Comet ML server, and just creating an account to the server and then logging into the Comet ML platform server, an engineer can track the machine learning model build process, and after the machine learning model is completed, you still have all those graphs, plots, and other metrics available for you to track the machine learning model performance. This tutorial is very useful. This tutorial is designed for engineers like me. So let's get started. This project, I already have these two sample Jupyter notebooks available at my Google Drive. And as of now, these two Jupyter notebooks are identical. So let me open one of them, which is the base one. And here is the Jupyter notebook. And I do have a really very detailed video tutorial available on using Keras deep learning framework to perform the machine learning. And here is that tutorial. So if you are interested in learning how to use Keras and perform EDA, network visualizations, real-time loss and accuracy visualization, plotting history and the model metrics, etc., please visit this Jupyter tutorial and you are going to learn more about it. So the same Jupyter notebook which I have used in this tutorial is going to be used in this Comet ML tutorial. So this is the Jupyter notebook I have, and I will be saving this Jupyter notebook to my GitHub account and export it. So saving a copy in GitHub. Oh, it should be public code. ProdRamp public code. So the path is ProdRamp public code, machine learning Comet ML, and because I already have my Google Colab connected with my public repo, that's why I could get these GitHub repos available to me, and I could save my Jupyter notebook. So it's creating a copy, and here you could see that it creates a folder in called Comet ML in the public code, and that Jupyter notebook is available here. Similar to that, I will be doing same thing for this one. Hit click. Let's open in Google Colab, and this is Comet ML, and we are going to do exactly the same. GitHub and save it. So now the Comet ML folder has these two Jupyter notebooks available in this Comet ML folder within the machine learning folder at my public code GitHub repo. So now you can pull the code from public code repo and you can get to work on these Jupyter notebooks. First, here I'm just walking through this whole Jupyter notebook, deep learning using Keras. Let's run. Select the dataset. So here we are uploading this hard dataset from my local machine to Google Colab runtime. Now we have this hard dataset available. Now we are importing this dataset. That dataset is available, and very first few EDA. So, and looking into the distribution of heart disease between male and female, and the just total distribution. Here we are doing correlation study among the columns in given data set. Finally, we are taking the target column out, so we can have the training and the target column separately available for us. And after that, here as you could see here, so I have df target and df training. So these two, df input and df target, are our two input data set. Next step, we are performing the data transformation here, and that takes that input data and convert into a scalar value of every cell value from every row. And now we are taking this input data set, which is the scaled input, and the target, and converting it into the train and test for our training, which using the 30% is split between the train and test. So out of 303 records, now we have 212 training and 91 for the test. Here we are using the training data set to split into the validation also. So now we have the training and validation data set. So there is a validation. So within the 212 record, we have used the 20% split between training and validation. Next, we are building this a sequential model using the dense layers. Model type is sequential, and there is the first input layer, which is using this 13 dimension for the 13 columns with the activation 10H. Then second is our dense layer 2, which is just a middle layer, and final, this is output layer, just using 1 for the output. And sigmoid is this activation, and that is because of our problem is related with binary classification, whether somebody has a heart disease or not. This is our model network look like. It shows that, okay, input layer, and then this is the dense layer, none is taking the 13, and then 30, and then finally 20 becomes 1. Our objective in this tutorial is to use the Comet ML and do monitoring and or observability for end-to-end machine learning pipeline. Here we are creating this plot loss method, and what it does is that when the training happens, after every epoch, it actually collects the information about the loss function. So this method actually helps us loss plot. Okay, so here we are compiling our model using optimizer is Adam, and then binary cross entropy is a loss type, and metrics for the accuracy. And as you could see here, that for every epoch as we are progressing, it actually prints the loss and validation loss. If you are interested to not only plot the loss and validation loss, you want to plot your accuracy as well for the training and the validation, you could function. These two functions I have taken from this gist. So if you are interested, please go ahead and you can study it more. So this is the regular loss with the training data, and here is the loss function, which is for the validation data. 100 epochs are done. Now here is our model summary. Here is the model accuracy, 98%, history, and if you look into the history keys, so we had loss, validation loss, accuracy, validation accuracy. We could plot this graph between loss, accuracy, validation loss, and validation accuracy. But if you would want to print this graph by yourself, here is some code available which you could use to plot your loss as well as the accuracy graph. So here is your confusion matrix, and finally here is your accuracy related with your model. So this is what our very simple heart disease prediction machine learning experiment using Keras. And this Jupyter notebook is perfectly identical to this one where we are going to implement the Comet ML. So let's come back here. Here, as you could see, almost identical. So let's start integrating the Comet ML. So in order to have the Comet ML integrated with your machine learning pipeline, very first thing what you need is you should have access to your Comet ML account. So you need to go to Comet ML, create an account. Here I am at the Comet ML console. I am already logged in with my business account, and I'm using the eval version or maybe individual version of Comet ML. And here within this product, if you look into settings, I can look into my API key. So here's my API key, and API key is copied. So that API key will be used wherever I would want to integrate Comet ML with my machine learning experiment. So here is our machine learning experiment with Keras, and we are going to integrate Comet ML. Here is the documentation related with Comet ML. So very first they want us to install the Comet ML. Pip install Comet ML. It looks like the Comet ML is installed, successfully installed. So after we have installed Comet ML, now we can use this Comet ML. So from Comet ML import experiment. Okay, so here we could experiment, and here we have to define the experiment and API key and the project name and the workspace. We can look into the sample for Keras. Let's here, and here we could say the experiment. Here is the experiment. So let's call it here experiment new. Here is the experiment, and we need to say API here. So this is the key, API underscore key equals here key, and want to see project name, heart disease. Okay, and we also have workspace name. We all workspace. So my workspace name is this default Avkash dash prodramp dash com. It means prodramp dash com. So let's restart. So experiment is live. So once we set this experiment, our API key is validated, project name, workspace is validated. Now, as you could see here, that experiment is live. It means if we go look into our experiment, reload it, you could see here that Keras heart disease experiment is available here. And it's just created, and that's all connected when we have this. Some of these settings we have set that auto metrics logging, auto parameters logging, histogram weight, gradient logging, activation logging. These are all true. If you want to learn more about these logging, you could see here, these are the different parameter which we can say that these are the environment. So what we want to true. So some of them we have already added true. Let's view the project, and here is our project. And we haven't even started anything in our Keras experiment yet. Now we are going to take this project side by side. Okay. Let me import the heart disease data set. We have heart disease data set. Now the heart disease CSV is available. We are importing some of these libraries, importing the data set. That's our data set. Columns. This is just a simple EDA. So I'm just bypassing this everything until I get to build with the network. And here we are, model type is sequential and the layers dense from the Keras, and here we are defining our model. Now if we look into experiment here, this is the place where we should be able to connection to our experiment from this Comet is already there, but as of now I do not see there is a lot more data. So far everything looks good. We are just looking into our network. Now let's compile and then start the training. Now the training is started here in the collab experiment. This is our experiment, and then there you go. And so we have started the experiment. This is the data is being picked up, and as we are progressing these epochs, here you could see that accuracy is coming, loss is going down, epoch time batch accuracy, validation loss, okay, and validation accuracy, validation batch loss. So we are seeing these metrics related with our experiment. So there were 100 epochs in this experiment, and they all epochs are 100. They're completed. Loss, accuracy, validation loss, validation accuracy, and here's the epochs. Okay, so 100. And as if you look into here, this is where the experiment. Now we can look into here. So these are the charts related with our experiment. Let's look into the metrics. And this is all related with our Keras heart disease experiment. So accuracy, so these are the metrics, and what we were seeing here is the charts. So looks like that collected. Backend is a TensorFlow sequential input layer, 13 input. That totally makes sense because that match with this. So this 13, 13, and then it's gonna be 30, then it's gonna be 20, then it's gonna be 1. So this exactly is this network which we are using. So this is totally understood by us. Metrics we have already understood here. That's the time, steps, everything. Okay, so that's okay. And output, and this is the log. So if we wouldn't have created this graph, or we could have written properly, we could have the exact same log here. Means if the callback was not being updated, because when we are updating the callback, that really repaint the log messages. So we do not see, but this is exactly the log we would have seen. So it also collects the log. Next is the system metrics. So this is the Google Colab runtime environment where we are running this notebook. So this is the CPU notebook. Okay, so system related metrics. Install packages. So this report from here. Notes is related with us. Any graphics image. So there is no image because our experiment was not related with image. Audio, there is nothing audio related. Text, nothing text related. Confusion metrics. The experiment did not log any confusion metrics asset. So let's run the model summary. So this is our model summary. This is model accuracy, 88.75%. So if you look into the metrics, this is our metrics, 88.75%. These are the precision, exact same, perfect. So that matches. History, and here is our accuracy and loss plot. So we have already seen those plots here. Validation accuracy, so which is red color, is the exact same way. And then we also have the validation loss, which is green. Looks that way. We started, and then that's where okay, so that's in this. Now let's print the confusion matrix. So here we are printing the confusion matrix, and if we look into here, confusion matrix, say it means if we look into here, if we want to enable the auto matrix, confusion matrix, I was expecting. Okay, next time we will enable all of these parameters and see. So that's why we do not have confusion matrix. Let's look into the histogram. So here is our network, 3 dense 2 activations. Let's go look into the experiment. Here is our experiment, this one, and let's look into the histogram. So, dense 2, 3 dense 2, it's an activation. Yeah. Parameter tab. So we have looked this other, this name, this is the ID given for this experiment, this is the notebook URL, and this parameter HTML does not log any HTML report. assets and artifacts, nothing like that. So here is the histogram, and which we have seen here. So as you could see here, we ran this Keras experiment in Google Colab, and we connected to Comet ML machine learning observability platform, and we could see all those results related with our experiment from start to finish. Means we had model metrics, we had runtime metrics, and then finally histogram and the final result. Notes. Histogram epoch rate. So we do not have auto histogram epoch rate. So let's take this and say log this one too. Let's use the log graph. Okay. Set up this experiment number 3. It will create experiment number 3. This is our experiment number 3. Data is already ready for us to do the experimentation. So once we did experimentation, we need to feed this model details, then how we are building the model. Then after, we need to run this thing. So now the training has started, and 20th epoch. And this experiment results are visible here for us. So these are the real-time metrics. If we click here, it takes a little time for us to see the logs, and depending on experiment, so it looks like this experiment has their colors. So all the 100 epochs are completed here, and because of that, let's see if hyperparameters. So these are the hyperparameters for this experiment. If we look into the previous experiment, which was here, and if we look into the hyperparameters, they were also there, charts were there, the confusion metrics, which says it was not logged, the previous one, but which is the very latest one, is here. System, we already see this thing, confusion metrics, it is not there. I need to figure it out how. Metrics, log confusion metrics, using experiment object to report a confusion matrix. So if I can use the experiment dot, if I come here at the very bottom, use experiment dot log confusion matrix, empty confusion matrix, push the experiment dot end. So we did experiment dot end. So all the metrics, logs, every data related with this experiment has to be pushed. So all files uploaded, waiting for confirmation. They have all been received. So experiment data is being pushed from Colab runtime to the Comet runtime. Let's go back to root. This is our workspace, and within the workspace we have these two experiments. So we have completed this experiment where we ran this heart disease Keras machine learning experiment at Google Colab, and we have seen all the metrics are being pushed related with our experiment to Comet server, and at the Comet server we had this opportunity to experience the results. Experimentation is completed now. So after our experimentation is completed, let's save this Jupyter notebook to the GitHub. I have replaced this API key with yours one, so you could replace as needed. Let's save this to public code, CometML. So here is the Jupyter notebook, which anybody could try with their own Comet API key. Let's quickly recap what we have learned. Very first thing is needed is that you need to have your account at Comet ML. You can use a free account, which is individual account. Once you have, Comet ML is going to give you an API key which is available in your settings. Here is your API key. So wherever you want to access your machine learning experiment parameters at the Comet ML server, you would have to make sure integrate that API key. In this hard to seize machine learning experiment with Keras, I have imported this experiment function from Comet ML, and I have set it up experiment with the API key, project name, and the workspace. And this workspace is available at the Comet ML server. So this is the workspace, which is my default workspace. So in this workspace, I have set it up that all these experiment related metrics will be logged into. And whenever we are going to compile the model and start the machine learning training process, all those metrics will be automatically being pushed from our machine learning runtime environment to the Comet server, and looking into our project and the particular experiment which is visible in this experiment definition when we are creating the experiment. And then you can start seeing those metrics. And after experiment is completed, you need to make sure is that if you are using Jupyter Notebook, then you have to use this experiment.end. And what experiment.end does is that it collects all the metrics which are available on runtime environment and push all of them to the Comet server. So that's all I had for you in this tutorial. I hope this test drive of Comet ML machine learning observability platform was beneficial to you, and I will be seeing you in my another tutorial. Thank you. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.